Okay, so today I want to go over the for loop, right? The for loop. So we just looked at the while loop, and so now I want us to look at the for loop, right? So let's just draw up the architect of the of the for loop. Sorry, right? The for loop. That's that's basically it. And then processing, right? And then this is basically when it, the end. Basically, that's what it is. So, so you're gonna begin by saying for, right? Start, stop, step. Let me explain what this start, stop, step is, right? So, unlike the while loop, the for loop needs you or requires you to be a bit more specific. You are basically saying that for, maybe say index or count, which is the example that we used in the previous lesson. If say count, so count is going to start at 0, and then you're saying that it should stop when count is maybe say equals to or less than 10. And then we're saying that it should step. So when it steps, we say that step, maybe say we want to increment, or step we want to decrement. It really doesn't matter. So when we're stepping, if you remember from the previous lesson on the while loop, we basically had a count variable. And the count variable was basically looping from 1 2 3 4 5 6 7 8 9 10. So when it looped for the first time, the count variable was now equals to 1. Looped for the second time, count variable is equals to 2. Third time, 3 4 5. So you can think of it as almost a similar thing, similar to exactly the same thing, right? So when we're stepping, we are telling the computer that, listen, I want you to go 1 2 3 4 5. Or we are also sort of telling it we want you to move in a positive direction, right? We can also go in the opposite direction and say, I want you to go, 0 1 -1 -2 -3 -4. So you can make it go basically backwards. You can make it go in a negative direction. But that's basically it, right? So it starts here, right? And then it starts, stop, step, processes, and then it ends here, right? So let's just do it for int. Let's just say int I is equals to 1, I is less than 10, I, let's just say I plus plus, right? Yeah, let's just say I plus plus, C out I, right? We want it to be one below the other, right? And so let's just try and compile this. 1 2 3 4 5 6 7 8 9, right? So it's going 1 2 3 4 5 6 7 8 9. It's not including 10, right? It does not include 10. The only thing that it does is that it basically goes from 1 up until 9. If we wanted to include 10, we could do this. We could just say whilst I is less than or equals to 10, right? And so now it's going to go up to 10, right? But that's not usually what we do. Usually what we do is you can say that, well, hey man, whilst I in a way, right, is equals to that, then you can just say plus 1 here. Right, so exactly the same thing. 1 2 3 4 5 6 7 8 9 10. So what have I basically done here? So we said that it should start here, right? So we said that it basically starts, right? So this line, it's just start and then stop and then step, right? That's what we've essentially said that it should do. It should start here, stop here, step here. So when it starts here, it's now starting. We are now saying that I is equals to 0, right? This concept gets a bit tricky when you're working with arrays or we're iterating over an array, but for now, it's just extremely simple, right? So we're saying that it should start at 0. So now it is starting where? At 0. And we're saying that it should stop whilst I is less than 10. So now what's happening is, now I say it should output I plus 1. So without the I plus 1, with just this is what would have happened, right? 0, 1, 2. It is going to continue up until, the last value was going to be 9. But with the plus 1, I'm now telling it that whatever value the I is at this point, which is 0, I want you to add 1 to it. 0 plus 1 is 1. Likewise with the second one, 1, add 1 to it is equals to 2. Likewise with the third one, add 1, it's equals to 3, right? So it's going to continue doing that up until it gets to 9. When it gets to 9, it's going to then say 9 plus 1, which is equals to 10. So that's basically, one of two ways in which you can do this, or you can try and I don't know, maybe cheat the system if you can call it that. But yeah, you can essentially just do it like this. So you can think of the I is usually called the index, right? I is called the index, and the reasoning being why I is called the index, it's because we use the I to basically get the position of a particular thing. We use the I to as the value itself, because what this thing is essentially doing is that we are having a particular value. I is a value, it's a variable, which is why I said integer here. I'm declaring a variable. I'm telling this variable that, listen, you are equals to 0. Because if I don't include the integer here, look what's going to happen. We're going to get an error, right? I was not declared in the scope. So I am declaring I. I'm telling the computer that, listen, I is equals to 0. Right? I want I to equals to 0. We are starting at 0. We are stopping whilst I is not less than, or whilst I is indeed less than 10. And we want to basically increment I. So I is going to be 1, 2, 3, 4, 5. So that's what's happening. That's the index, right? We are trying to basically get the value of the index when it loops for the first time, loops for the second time, loops for the third time. As it's continuing looping, we need to keep track of how much has it already looped, right? Because if we had no way of keeping track of exactly how much the particular thing has looped, then we honestly would not be able to give it a condition. We would not be able to tell it to stop at 10 if it has no way of tracking where exactly or how much has it looped. So that's essentially the entire thingy about, or the entire context of having an index, is that it allows you to have a value that you can use to then find a position of something within the entire loop. So that's those are just basically for loops, right? In general, those are just for loops. That's what a for loop can basically do. But what I want to do is I want to then sort of say this, right? Right? So it's going to essentially just be going down all the way down up until negative infinity. And the reasoning why it's doing that is because I told you guys earlier that when we say, or when we are stepping, we can either step it to be positive, to be incrementing it. So basically when we're stepping, right? So we say step, we either want it to increment, and when it's incrementing, it's going to be 1, 2, 3, 4, 5, 6, 7. But what you need to understand is that do not look at this step and think it's the last thing, and think that it's just something that we do. It has no condition attached to it. It does have a condition attached to it because we are telling the computer that I want you to increment up until I is less than 10. So then it increments up until I is less than 10. But now what happens if I'm saying do not increment? Instead, what I want you to actually do is start at 0 and then go -1, and then go -2, and then go -3, right? And then go -4. It's going to continue because it's not going positive. It's going in a negative direction, right? It's going in the left. I know that I put it, it's basically going towards the right, but it's going towards the left, right? If you look at the number line or the number system. So it's never going to approach 10. It's never going to get to 10. In fact, it's actually going to be growing further and further and further away from 10, which is why it's going to be looping up until negative infinity. So that's why I just want you guys to not get too comfortable with this increment and think that this is basically what we need to do. This is the template to creating a for loop. It's not the template to creating a for loop. You can have, different things. You can even say whilst I is less than 10, say, I don't know, like +1. Whilst, I is less than 10, multiply. You can do a lot of things basically, right, to try and customize your conditions, right? So that's what a for loop essentially does.